So let's take a look at what happened to the Earth. So we know that the Earth has life on it. We can specify 4 specific reasons why this is the case. 1, the Earth has liquid water on its surface. 2, it has atmospheric oxygen. 3, it has plate tectonics. And 4, it has climate stability. So all life as we know it, from the smallest bacterium to the largest whale or plants or whatever, all life as we understand it requires liquid water. Part of the interest in this idea of liquid water can actually help us understand where to search in the universe for life. We have this idea of follow the water. If there's liquid water, then we have a chance for life. Something else that helps life on Earth is oxygen. Okay, right now, the Earth has abundant oxygen in its atmosphere. As we look at the components of the Earth's atmosphere down here in this table, it is 78% nitrogen and 21% oxygen. That is actually very strange as we compare it to Venus and Mars. Now, Venus, Earth, and Mars all formed at the same time in the same place in the same way, so we kind of expect that they should be the same. But we see that Venus has about 3.5% nitrogen and Mars about 2.7%, and their atmospheres are predominantly carbon dioxide. Venus is around 96.5% carbon dioxide, and Mars is around 95% carbon dioxide. We actually believe that the Earth's atmosphere likely began at the same place. So how did the Earth get so different? It actually comes from a couple of things. One is the temperature of the Earth. The Earth has liquid water. As the rain falls, it's going to absorb some carbon dioxide. That carbon dioxide-rich water then is going to pool in the oceans, and over time, some of that carbon dioxide actually gets locked away within rock. So what this means, over time, we actually decrease the amount of carbon dioxide in the atmosphere, increasing the amount of nitrogen. That's part of it. The other thing that happened to the Earth is that the Earth developed life. The very first types of life on Earth were actually anaerobic, meaning that they did not use oxygen. In fact, oxygen is toxic to anaerobic life. However, some of this anaerobic life eventually developed photosynthesis. Okay, so photosynthesis, you're probably familiar with plants. Okay, so plants breathe in carbon dioxide and actually give off oxygen as a waste product. So this early form of life, it's what we refer to as cyanobacteria, so kind of a predecessor of modern-day plants, actually began breathing in carbon dioxide and releasing oxygen into the atmosphere. Now at first, this oxygen would react with rock. Oxygen is a very reactive element, so you can kind of think of the Earth as rusting over during this period. But eventually, the crust became saturated with rock, and so the oxygen began to build up within the atmosphere. So that over time, there got to be more and more oxygen until we get to a point where life that uses oxygen and gives off carbon dioxide was able to develop. And then we have a balance between the oxygen producers and the oxygen users that has leveled off at around this 21% that we have today. So part of the reason why the Earth is so different from Mars and Venus is because it developed life. So 1, liquid water, and 2, life. Another piece of the Earth being habitable or being able to maintain life is its tectonic system. So through natural processes, both biological and geological and chemical, the nutrients, the things that are necessary for life, will eventually get absorbed and placed into rock, where it's no longer usable. However, because of the tectonic cycles, old crust is constantly being destroyed, and then some of that material is then re-released through volcanoes. So it's then put back out into the atmosphere or out into the surface of the Earth where it's going to be able to be used again. Another piece for the Earth being able to maintain life is that it has climate stability. There are several processes that have kept the Earth with this nice liquid water temperature for pretty much all of its existence. One of these is the carbon dioxide cycle. So what happens is we have carbon dioxide in the air. So a lot of this was actually released through outgassing from volcanoes. As rain falls through the air, it absorbs some of that carbon dioxide, which then as the water pools in seas and oceans will get locked away within rock. Well, eventually, that rock is going to be destroyed through volcanism, so through volcanoes and tectonics, and that carbon dioxide then gets released back into the atmosphere. Well, these sorts of cycles are self-adjusting. So, for example, if the Earth heats up too much, then this is going to lead to more evaporation and more rain. With more rainfall, it actually pulls out more carbon dioxide from the atmosphere, decreasing the total amount of carbon dioxide and therefore reducing the greenhouse effect. With less greenhouse effect, it actually ends up cooling off. So we started heating up, and then the process allowed it to cool back off to the nice stable temperature. On the other side, if the Earth begins cooling off too much, then this means we have less clouds and less rainfall, but through outgassing through volcanoes, this is going to then increase the total amount of carbon dioxide in the atmosphere, which leads to a stronger greenhouse effect and therefore a stronger temperature increase. So we started a cooling trend, which then got corrected until, again, we get back to the nice stable climate that the Earth has had for most of its history. Now, although the Earth has had a relatively stable climate for pretty much all of its existence, the current concern with climate change and the greenhouse effect is how quickly these things have happened. It usually takes thousands or tens of thousands of years for these cycles to happen, but we see a rapid increase in the last 100 years. With how fast this is happening, the concern is that we're going to break the cycle. More particularly, what will probably happen is that the Earth itself will be fine, but we may make the conditions unsuitable for present life, meaning that our civilization could be in danger. We actually see several species becoming extinct because of this rapid increase in just the last 100 years. So the concern is we're breaking the cycle. We need to slow things down so that things can get back to the normal processes. All right, so we understand what happened to the Earth. So what happened to Venus? So again, Venus, Earth, and Mars all formed at the same time, in the same way, in the same place, so they should have started out similarly. Well, the problem that Venus has is that it did not have liquid water. So because of that, more carbon dioxide was able to build up in the atmosphere. As you get more and more carbon dioxide, this leads to a stronger and stronger greenhouse effect, which is going to lead to very bad things. Specifically, we believe that Venus had what we refer to as a runaway greenhouse effect. Early on, it is actually likely that Venus did have liquid water, but through outgassing, it got more and more carbon dioxide, which caused things to heat up so much that the liquid water oceans that it may have had actually began to boil. And that means that we now have water vapor that is now contributing to the greenhouse effect, which causes it to get hotter, and then more outgassing from volcanoes until everything gets so incredibly hot. So Venus is actually the hottest planet in the solar system because of this, because of the greenhouse effect. Even though it's not the planet closest to the sun, it is the planet that is the very hottest. Okay, so then what happened to Mars? Mars had the not exactly the opposite, but almost the opposite problem as Venus. Mars is about half the diameter of the Earth. It also has a much weaker pull of gravity. The surface gravity on Mars is about 1/3 the surface gravity of the Earth. So what happened is Mars is so small that the interior is cooled off to the point that Mars no longer generates a magnetic field. And with the weak gravity that it has, the solar wind has actually been removing the atmosphere from Mars. So over time, as Mars has lost more and more atmosphere, it's reduced the amount of the greenhouse effect. So this is what is sometimes referred to as an icehouse effect. It has gotten colder and colder until Mars has actually frozen over. We have very strong evidence that Mars actually did have liquid water at one point in the past, to the point that there were actually seas. There is sedimentary rock that can only be formed at the bottoms of lakes from the motion of water that we find on Mars. But because it has lost its atmosphere and it has cooled off, all of that liquid water has slowly been locked away as permafrost and in the polar ice caps. Okay, so what we see from all of this is the size and position of a planet are very important. So we know that the Earth has life, and we went through 4 reasons why, but we can narrow those down to 2 specific reasons for why the Earth has life. The Earth was at the right distance from the Sun. Because of where it was positioned from the Sun, it was able to maintain liquid water. Too close, and it would be like Venus. The water would have boiled, everything would have heated up, we'd have a runaway greenhouse effect. Too far away, and it wouldn't get enough sunlight, and it would actually freeze. The other piece is that the Earth is the right size. Because of how large the Earth is, it's maintained the internal heat, which means that it is still geologically active. So we still have plate tectonics. We also have the geologic processes that lead to things like the carbon dioxide cycle that lead to climate stability. Also, because of the size of the Earth, it's big enough that it has enough gravity to have maintained an atmosphere for its entire existence, which is also necessary to maintain liquid water and these other processes that are necessary for life.